Hello everyone, Mech Obsessed Lunatic here. In today's video I will show you how to make a simple design mech. Nothing too fancy, just a bare bone version so you can make something stable and that works well. Now, the script that I'm using in this video is subject to change in the future and is not fully released yet. Therefore you may ask yourself, why in hell are you presenting us something that isn't out yet? The script is present on many mechs on the workshop already, so you can scoop it out of its programmable block and use it to your liking. Alright, hope this tutorial will be helpful, and let's get started. The two hinges I'm placing right now will help for a side step or a slight angle for more dynamic poses. I'm currently naming them SL and SR respectively. The R stands for right, the L stands for left, and we will be using rotors as well. I'm calling them HR and HL. The plus sign determines essentially if the rotor will play the animation forward or backward. So HR for hip right, HL for hip left. Then we extend the thighs, and we place the hinges to mimic the knee. And now we name both of them. KL plus for knee left, and KR plus for knee right. Now we extend the lower part of the leg. I will be placing two hinges facing inward. The reason is to mirror the one that are between the rotors above. That way the foot can stay parallel to the ground. They both have the same name as those above, therefore SL plus on the left leg and SR plus on the right leg. And then we have the feet, a simple F, FR for feet right, FL for feet left. Then we make somewhat of a fit, though not too complicated. Right here we will focus on how to make something functional, not look good. Then we can place a rotor or not, that's entirely up to you if you want a torso twist. Any cockpit will do, it just depends on how you want to build your mech. Now, the structure I'm preparing right here with a rotor is for a stabilization system. One that will use AI blocks. How this system works will be expanded upon very shortly. Now, you want an AI basic task and flight pattern. The flight pattern will have an F that you must make face forward. Now create a GPS point that will have the Z-axis and X-axis extremely far away from you. The reason why is because we will tell our AI to follow those sets of coordinates. As for the settings of the AI, we go as follow. AI behavior on, select objective, follow home, and then simply click on the coordinates. Now for the flight pattern, AI behavior on, collision avoidance off, speed limit to max, minimum altitude to 0, and max pitch angle to 1 and minimum to 1. Now, as for what this is needed, the reason why we want max speed is otherwise if it is reached somehow by your mech, the AI will simply try to slow down and this may get finicky. If the altitude is above the size of your mech, it also can create problem. Align to gravity because this is what interests us the most. And max pitch angle and max roll angle is set to 1 degree so that the AI will not try to exceed this. If your mech starts to tilt over, the AI will sense that its tilting point is beyond 1 degree and will try to correct. As the reason why it's not 0, it's because the AI hardly supports such a drastic setting. Now the reason why we want the AI to follow these sets of coordinates is because the AI have an interesting particularity, especially on the flight pattern, which is aligned to gravity. This feature has been replicated with scripts, but unfortunately, they are not as powerful as AI when it comes to controlling gyroscope. Therefore, we will be using this system for now, and I will present a second one later on. Right now you see me fiddle with the different settings of the rotor and turning on inertia tensor. This is needed for the stabilization system to perform well, otherwise the mech may jitter around. Then place a bunch of gyros everywhere, including on the main structure of your grid. Now a bit of explanation on how this system works a bit more in depth. The reason why it's placed on the rotor is because right now the AI absolutely want to follow the sets of coordinates we've pre-established before. The problem is that if it is set on something that cannot turn, it will override your control of your gyroscope. Granted, even if it is on a subgrid, it will do so just through sheer power, and it will physically turn your construct to look toward that set of coordinates. Therefore, since it is on a rotor, it acts as a pivot and can look freely where it wants, while still be able to keep that particular settings that is aligned to gravity. The problem with AI is that aligned to gravity is not an action in and on itself. It needs to perform something or have to do something in order to use aligned to gravity. Therefore, we ask the AI to go somewhere. It cannot physically go there because it doesn't have any thrusters. Granted, it can look in that direction and will try to go there, but instead it can't, therefore it will just align to gravity and stay on our grid. Moving on. Now we just add a source of power on the main grid, since the reactor is on the pole that will be dismantled afterward. And now the bread and butter of mech building. Granted, there is always timer block that could be used, but right now we will focus on scripts. This is MCS, a script developed by Commander Storm and Eternal Colossus that is solely meant to help building mech. Right now I'm turning inertia tensor on both of those hinges to avoid tremors. Same goes here. Now the reason why I do it on those hinges and not on the rotors is because those hinges have a very small range of motion. Therefore, inertia tensor won't have too much of an impact on how the mech plays. Now, the reason why we named our hinges is so that the program of the programmable block can detect and utilize them. Same goes for why I checked the box of main cockpit. Now the program knows that this is the cockpit that will be used to control the mech. You can in turn rename your programmable block how you see fit, depending if you have multiple on your mech or if you just want to have something sorted. As you can see right here, the alignment of the construct is quite poor, and this is where we will look at another setting that is very interesting, courtesy of the script. You can go in the custom data of any of your mech related part. In that case, we'll go on SL+, go into custom data, and here you will have a plethora of new options. Right now I am modifying hip offset. This option will help you modify the angle at which your articulation rests. In that case, I modify it to be according to what I need. Granted, your mech may need a few more tweaks, or may not, depending on how you built the leg. Now I'm modifying the offset of the feet so it can stay parallel to the ground. I overdid it, therefore I just make a slight modification. Again, a minus or absence of minus sign in front of those numbers will determine where, in which direction your hinge or rotor is rotating, either in the positive or negative. And here, as you can see, we also have a few custom data inside of the programmable block. They are all pretty straightforward. Acceleration multiplier is how fast the animation will start playing once you press your forward key, backward, left or right, depending on which action you want to perform. deceleration is how fast this animation will stop playing. Now, even though we have torso twist here, I will utilize another script, but that's just a preference of mine. Independent step true or false will simply play the animation after the first animation has been finished. So step by step, instead of a more fluid animation. The control for the script are as follow. WASD for moving sideways, forward or backward. And then you have C and spacebar to crouch and jump. Right now I'm doing a first test. If your construct is a bit too wobbly, you may need more gyroscope in override. A gyroscope in override will counteract a rotation. Not prevent it, but it will slow it down substantially, which may help to avoid wobble or tumbling down, which shouldn't be the case if you have a correct stabilization system. Now the next part I will show in the video is me mostly tweaking the different settings so that I have a better working animation, as in something a bit more fast. Here I modified another set of settings to have my legs more straight and not bent all the way. Now I'm going above 100% when it comes to step length, even though the script will show an error message. This should not prevent you from using the script, but it may cause trouble later if you overdo it. Now, if your mech lose grip, slide on the ground or slide backward, and the animation lose grip, you can increase the weight of your mech by all kinds of means, be it heavy armor, in that case spaceball, artificial mass, all kinds of stuff. All of the settings in the script are named to make things easier. Now, if your mech lacks stability, you can simply increase the number of gyroscopes on the stabilization system. Now, the next part that I'm about to show you is another type of stabilization system. This one is more compact, but has a caveat. For this one, again, we will need the two same previous AI blocks, both of those set on a subgrid. As always, make sure that your flight pattern is facing forward and place the number of gyroscope needed. Now we align it properly. And the next crucial part is a beacon. Now the way that this works is that instead of having the AI follow a random set of coordinates, they will follow the beacon. Since the beacon is already just beside the AI block, it doesn't have a reason to try to turn around or go somewhere, therefore it just aligns to gravity. Now, make sure to name your beacon correctly and something that you can find easily, and maybe reduce the emission range so it doesn't confuse other players. And as you can see, more compact still works very well. Now, one of the big problems of that mechanism is that it does not play well with copies of itself. As in, if you have two mech with the same instances of this particular stabilization system, it will lag severely. Here is another mech with the same stabilization system. Now, if you look on the left top side of my screen, you have a set of data, including FPS. Watch what happened when I paste two of those. As you can see, sim speed dropped tremendously. Needless to say, the more you add, the worse it will be. So use this one at your own risk, or if you play solo, or if you just want to showcase something. Now for the torso twist, again, you could just name it TT uppercase with either a minus sign or plus sign. For MCS to take care of it, me personally, I like to use Blag Hinge Steering. For Blag, you will use the tag #steer. This is how Blag detects the block that is related to his script. Right now, steer is by default related to W and D. Both of those sets of keys are related already to MCS, as in, as I'm trying to go left and right, or look left and right, I try to sidestep at the same time. Therefore, what I will do instead is add another tag, which in that case will be yaw, which is essentially a rotation on the y-axis of the mech. Therefore, now, when I look around, yaw is tied to the mouse for left and right movement. As you can see, my cockpit move as I'm looking around. Now, if you want to turn the whole mech, you can have a lock and unlock option on the rotor of the torso twist on your toolbar, so that you can choose to lock it in place and move the whole structure. Then if you need to, you can have more gyroscope in override. In that case I'm adding one below the torso, so it should help not move the leg too much around. Again, it will help prevent a rotation but not stop it entirely. And as you can see, you can do all kinds of stuff with your mech. You can jump, you can go backward, you can go side to side. It's up to you on how you want to modify the option. Now, what I'm looking at right now is a variety of options. As you can see, we have humanoid, chicken walker, spider-rod, crab, digitigrade, and prismatic. Right now, I will replace leg type 1 with just the number 2 instead of the 1. This will automatically make the transition from humanoid to chicken walker. Those two are extremely similar, but instead of the knee bending forward, they bend backward. Then you simply rerun your script, and as you can see, I now have a chicken walker. Now a good demonstration of how powerful the stabilization system. As you can see, just defy the center of gravity of the mech, and just keep it upright no matter what. Even if I fight it, it's powerful enough, I'm not using my mouse right now to help, to just have me back up. Hope this tutorial will be helpful. Keep in mind MCS may experience... Hope this tutorial will be helpful. Keep in mind the script MCS may experience some change in the future as it is still in development. But right now a lot of people are having trouble with scripting or are too afraid to get into mech building. Therefore I hope this tutorial will be helpful to you. Alright everyone, have a good one and see you around.